Hi, EF-7, last lesson in this whole unit. So, this was actually a very good unit for y'all to do independently because it's not overly difficult. But what does this look like moving forward? Okay, so today is EF-7. Tomorrow we're going to do a little bit of a mix. That's going to be independent. So, there's actually not going to be a video. It's just a Delta Math assignment. Monday, you have off, Martin Luther King Day. I have a dream. Tuesday, you are going to be doing a practice test if you're in class, also a practice test if you are home. Wednesday will be another makeup day. Thursday and Friday, you will be testing. Okay, so let's hit it. This is basically the cultivating thing. So this is how we're putting it all together. This is what you're going to see normally. So you're going to see word problems with this, okay? Let's start. So the current population of a town is 10,000. If the population increases 20% each year, which equation could be used to find the population after T years? The first thing I want you to recognize, you have a percent. If you have a percent, you are all people won the race together, okay? Where R is that percent in decimal form, okay? So it tells you population P. So that means that my population has to equal what? Well, P is what it starts with. I started with 10,000 people in the town. Parenthesis 1 is part of the equation. Now you have to determine if you're adding or if you're subtracting. Well, it tells me right here, increases. So I'm adding. Increases by the rate. Here is the rate. I need to turn 20% into a decimal. Otherwise, it's not going to work. Okay? And that's when we listen to Beyonce and we say to the left, and we move that decimal place 2 to the left. So we have 0.20. So 1 plus 0.20. And it says T years. So T is the time. So that's what you're going to use as your exponent. Here is your equation. It doesn't tell us to evaluate at any time, so this is just it, okay? Next one, and also another common one. Kathy plans to purchase a car that depreciates. You're going to see this word a lot. It usually won't say next to it loses value, okay? So depreciates at a rate of 14%. Bingo, I see 14%. That means all people won the race together, okay? The initial cost, 21,000. Write the equation that represents the value V of the car after 3 years. Okay, so represents the value. So value is going to equal. P is my principal amount, how much I start with. I start with 21,000. Parenthesis 1, part of the equation. Is it gaining value or is it losing value? That's how I know if I'm adding or subtracting. Losing value, depreciates, means it's losing value, okay? At what rate? So 14%, Queen B says to the left, that's going to give me 0.14. So I get 0.14. And then here would normally be a T, but they gave us a 3 because 3 is what I'm actually looking for, okay? So let's look at this value. So I start 21,000, oopsies, parenthesis 1 minus 0.14, all to the third power. And it says after 3 years, your car value would be $13,357. Notice you don't get 0.176 cents back at the grocery store or the market or wherever you go. You only get like a dime or a quarter. So 10 hundredth to the hundredth. So we're going to round to the second decimal point. So what that would mean is you would get back 6 pushes are up, so 18. Very valid. Your car value drops a lot. So when you get a car, just know that. A high school sponsored a badminton tournament. After each round, one half of the players were eliminated. If there were 64 players at the start of the tournament, which equation models the players left after 3 rounds? Okay, so at this point in time, I don't see anything that gives me a percent. So no percent usually indicates you are at y equals a times b to the x, okay? But this is no different. A is how many players you started with. B is your growth value, so what they're telling you to multiply by. X is the amount of time. Okay, so how many would be modeled after 3 years? Well, Y equals how many players started? 64 players started. Okay. 1/2 of the players are eliminated. So what is my growth factor? They're getting smaller by 1/2. And then X would be our exponent. If I wanted to know how many players were left after 3 years, I just put in 3 right here, or 3 rounds, I'm sorry. So I have 64 parenthesis 1/2 to the third. So after 3 rounds, I would have 8 left. Another way you could look at this, I start by having 64 players. I lose half of them, so I divide by 2, okay, 3 times. Okay, I'm left with 8. So I just basically found the pattern in the table. Okay. All right, last 3 questions. So this one was on a Regents. These 2 are the last 2 questions, and these are both Regents questions. And what does this one say? Rachel and Mark were given the information shown below about the bacteria growing in a petri dish in their biology class. Up top, I have numbers and hours. So these are the numbers and the hours. And this is the number and the bacteria that they had after those numbers and the hours. Rachel wants to model this information with a linear function. Mark wants to use an exponential function. Which model is the better choice? Explain why you chose this model. Notice it is not asking you to write an equation. It is simply saying which is a better fit. Okay? Which would work better? And the only thing that we need to know is what is the difference between a linear function, how that grows, or an exponential function, how that grows. Okay? The only thing I need to know is how these numbers are moving. So at the top, I'm going by 1. So these are all plus 1. Good. Now, down at the bottom, how am I moving? So how am I getting from 220 to 280? So I'm going to do 280 minus 220. So this says I would be adding 60. And if I were multiplying to get to the next number, I'd have to divide these 2 numbers. So notice how I'm looking for the opposite. If I want to know how I'm adding to there, I need to know the difference between the 2. If I want to know how I'm multiplying, I need to know division of these 2. So 280 divided by 220. So I'd be multiplying by 1.2727. Okay, that's repeating. Okay, so what's going to happen here? 220 plus 60 equals 280. 280 plus 60 equals 340. Is 340 350? Are those 2 equal? No. Okay, so right now, I don't even have to do anything different. I know for a fact that this is not a linear function because I am not adding the same amount each and every time. Okay, so Mark is the one who has the better model. So Mark's model of an exponential function would be the better choice. And it says explain why you chose. So I'm going to say because the amount of bacteria is not growing at a constant rate. Okay, so what does that mean? It means that I'm not adding the same amount every single time. So my rise over my run doesn't exist. Okay, so it's not going up, over at the same amount. Okay, so basically, if you ever are asked a question like this, all you have to do is say, do I add to get to the next number? And if you don't, it is not linear. Okay. All right. Last question. Michael has 10 in his savings account. Option 1 will add 100 to his account each week. Option 2 will double the amount in his account each week. And what we want to do right now is write a function in terms of X to model each option of saving, okay? So I'm going to write option 1, and I'm going to write option 2. Okay. So Michael has $10 in his savings account. So that means that no matter what, he always starts with $10. Okay. So this one, option 1, will add $10 to his account each week. Okay. Option 2 will double the amount in his account at the end of the week. All right. So what happens here? I'm seeing the word double, and I'm seeing add. Okay. Adding the same amount each week, just like we talked about here, adding indicates a linear function. Doubling is one of those multiplication words. This indicates an exponential function, okay? So no matter what, I have y equals, okay? I'm going to write what he starts with. So Michael starts with $10 in his account, okay? And the exponential function starts with $10, and the linear function starts with $10. In option 1, he will add, okay, it's telling me to add $100 each week, okay? Now, this says write a function in terms to model, or of X to model each option, okay? So that means that X is going to go here because that's my modeling term. So I'm going to plug in things for X to see how much money he has. So Y equals MX plus B. B is what we began with, and M is how much we're putting in weekly. Option 2 is my exponential. So to remember, it would be Y equals A times B to the X because I'm using a word like double, no percent. B is what I multiply by. A is where I start. So Michael starts with $10 and it will double. So double means multiply by 2 each week. Okay, there is my 2 equations. Now, part 2 says Michael wants to have $700 in his account at the end of 7 weeks to buy a mountain bike. Determine which options will enable him to reach his goal. So all we do here is plug in 7. So option 1, the money he'll have after 7 weeks is $10 plus the $100 for 7 weeks. Okay, I think we can do this in our head, but $710. Alrighty, and then option 2 says Y is, I start with 10. I'm going to double that for 7 weeks. Okay, so 10. Which one do you think is going to be bigger? Oh, yeah. Exponential functions are way bigger all the time. 100 sounds like a lot each week, but doubling something is way bigger, okay? So he actually has enough to for both options. So determine which option will enable him to reach his goal. Anytime it says justify, this is your justification. Justification means math, as opposed to explain. Explain means use your words. Okay, so this is my justification. So now I'm just going to answer both options will allow Michael to buy, what is he buying? A mountain bike after 7 years. All right. That wasn't hard, right? All right. So what that means is we're done. And now you are off to your homework. Have the best day.